welcome to video 4 of lecture 2. Today we will talk about some very important concepts related to conditional probabilities, such as what is an independent event, how we should not confuse them with disjoint events, what is Bayes' rule, what is the law of total probability, what is the multiplication rule, and we will finish up the topic of conditional probability. So sometimes in probability we say that two events are independent. And what do we mean by that? So imagine that I want to know if it's going to rain tomorrow. The probability of rain is 1/3. And the probability of me tossing a coin and getting heads is 0.5. So because these two events are unrelated, they don't influence each other, I can know for certain that the probability of rain tomorrow, given that I may get a heads, equals to 1/3. So the probability of one does not influence the probability of the other. No matter if B happens or not, the occurrence of the event does not change the probability of occurrence of A. And if we recall the formula from conditional probability, we can say that the probability of A given B equals the intersection of A and B over the probability of B, right? So the only way that the events can be independent is that if the probability of the intersection equals the probability of A multiplied by the probability of B. And that is what we call the multiplication rule. The multiplication rule only applies for events that are independent. So independence means that the conditional probability of A given B equals the prior or the original probability of A. And also that I can multiply the probabilities of A and B to get the probability of their intersection. But there is a common mistake in probability. Sometimes we confuse disjoint events with the concept of independence. And those are completely different. Because if you come to think of it, if you say some events are disjoint, you are saying that their probability of intersection equals 0. And if the probability of intersection equals 0, then it's not equal to the probability of A multiplied by the probability of B, meaning that they are not independent. And this is intuitive, right? When we say that two events are disjoint, we say that when one occurs, the other cannot possibly occur. The probability of the intersection, it's 0. And that gives us a lot of information. And independent events, by definition, are events that give no information about the other, about the occurrence of the other. So these are two completely different notions. So summarizing, disjoint events, the probability of the intersection equals 0 because when we intersect the two events, we get the empty set. The probability of the union of the joint events equals the sum of the probabilities of each event. That's one of the axioms of probability theory. In the case of independent events, we are talking about completely unrelated events that when one occurs, that doesn't give any much interesting information about the other. So the probability of A given B equals the probability of A, the probability of B given A equals the probability of B, and the probability of the intersection is the multiplication of the probabilities, the famous multiplication rule. Sometimes we want to calculate the probability of a given event, and we only have access to some conditional probabilities. And in that case, we use the law of the total probability. Let me give you an example to the intuition behind the law of total probability. So consider that in a country you have 3 regions, region B1, B2, and B3, and you want to calculate the total forest area. How do you calculate it? Well, it's simple, right? You just add the forest area in region 1 with the forest area in region 2 with the forest area in region 3, and that gives you the total forest area. And that's pretty much the intuition for when you want to calculate the probability of an event given a partition. And what is a partition of a sample space? Well, it's basically the same idea of having the regions in the country. You just divide the sample space in a set of disjoint events that enclose the entire sample space. And in that case, the probability of a given event A equals the sum of the probabilities of A with each of the regions in the partition that you considered of the sample space. And because you know the formula of the conditional probability, you can change the denominator from one side to the other, and you can replace the probability of the intersection with the formula that contains conditional probabilities, which may be easier to calculate than the probabilities of the intersection and the probability of the event altogether. A special case that we can consider is the case of two events, event A and event B. You can partition the sample space looking at the event B and the complement of the event B. So the B and the united with the complement of B enclose all the sample space. It's partition of the sample space. So you can say that the probability of A equals the probability of intersecting A with B plus the probability of A intersected with the complement of B. And with the definition of conditional probability, you can rewrite the formula. But perhaps the most fundamental formula that has to do with conditional probability is Bayes' rule. And Bayes' rule has to do with the fact that sometimes to calculate the probability of A given B, I can use the probability of B given A. And how do I do that? Well, I use Bayes' rule. Well, we know from the original formula of the conditional probability that the probability of A given B equals the probability of the intersection over the probability of B. So the probability of the intersection equals the probability of A given B multiplied by the probability of B. But because the probability of B intersected with A equals the probability of A intersected with B, we can say that the probability of A given B multiplied by the probability of B equals the probability of B given A multiplied by the probability of A. Dividing by the probability of A, we get Bayes' rules. And using the law of total probability, sometimes we rewrite the rule of Bayes in this way. So today we talked about independent events and why independence does not mean that they are disjoint, and these are two very separate concepts. We talked about the multiplication rule for independent events. We also talked about the Bayes rules and how it can be rewritten with the total law of probability. Fundamentally, when we talk about the law of probability or Bayes rules, we are just talking about alternative ways of calculating probabilities using conditional probabilities. And that's it for today. I hope that you have enjoyed the lesson, and see you next lesson.